Hello and welcome to the video on microcontroller instruction set 8085 8051 microcontroller instruction set will be discussed. What are the different types of instructions and what the use of an instruction in the 8051 microcontroller programming would be discussed. First, coming to the topic on why an instruction is being required in your 8051 microcontroller. So first of all, 8051 microcontroller. When you go for 8051 microcontroller, it is a machine. And every machine requires a commands to be passed to the machine. So here, when you go for 8051 microcontroller, there are totally 111 instructions given over here, provided over here. So these instructions are just like the words given to the machine or the commands given to the machine, and the machine will act according to these instructions. So instructions plays a quite important role in 8051 microcontroller or any microcontroller microprocessor. If you take without instructions, you can't do the work of the instruction. When is do the work of the machine which are using. So to this, there are different categories of instructions which we need to learn it up when we are using this microcontroller 8051. What is this category? First one is that if you want to transfer a data to one location to another, you'll use data transfer instructions. If you want to make the machine use of arithmetic operations, you will go for arithmetic instructions. If you want to go for logical operations, we will go for logical instructions. Logical instructions with bits, and this is a special case in your 8051 microcontroller. It is not available in their microprocessor because the 8051 has a Boolean processor. And this is obviously the same thing, branch instructions which are common to us. Coming to this category, data transfer instructions. These instructions are used to move the content from one location to another location, or from one register to the memory location, to another location to the register, or from the IO ports, moving a data from that one, or from the stack, we will need to give the value into the stack. We need to store the value into the stack, or take the value from the stack. And so all the process is being done using of this data transfer instruction. So the first category of data transfer instructions, we'll take it as a move instruction. This is one of the most important instructions. The move instruction, one thing it could be there, it can't move a value from one location for source and destination can't be memory location. So if you are having a source as a register, the other may be a register. If your source is a register, it may be a multiplication destination. So like that way, source and destination can vary accordingly, but immediate value to the so the memory location or maybe is not possible. And both here. Yeah. So this is a simple section. According to the movie section, you can see these examples. E comma hash x indicates some data value. So you are moving a data value in an A register, from A register to the RN register, from the bank registers of RN to RX register. Any number that you are provided with it. So here both are these bank registers are being used in this example. Like this way, you are having a different categories of move instructions or examples have been given. Coming to the next one, if you want to take into consideration of move C is required when you go for a program. If you want to take an code from particular location, we can use this. Provided an external memory, we need to have as MoveX. This is the three categories we will be having: simple mode, movie, and MoveC is for program memory, and Move is for external data memory. So you can have the data taking up the external data. And the next one is that you can have an push the values and pop the values from the stack by using a push and pop. I mean to say collect the value from the stack and store the value to the stack using a push and pop. And the next category is data transfer instructions will be having is exchange. Exchange what it does is that as you know that the value in Rn exchange A comma Rn means A value would be stored in Rn, Rn value would be stored in A. This is one of the very different type of data transfer instruction, CSD. Now, what happens over here is that the with the accumulator, the four bits are being copied to the higher 4 bits, and the higher 4 bits are being copied. So, so the automatically it will take into consideration of a register only. Next, we will be having a category of arithmetic instructions. These are very common instructions. Already we have discussed in your 085 and 086. So once again, this is an revision. So I'm moving very fastly. In arithmetic instructions, we have addition, subtraction, multiplication, increment, decrement can be performed. So as usual, here one thing in taken into consideration, A should be the destination. You should have a fixed destination as A, and anything you can take an register value, you can add it to the over here, or you can go for a simple take an immediate value, you can take an memory location, anything you can take. Destination should be an and with Kathy, we are having over here as ADDC, so it will include the calculator also added. Similarly, you are having an subtract instruction SUBB, so where it will be the instruction of God also. It's a direct language would be taken. So for all these instructions, again, you can have either a register or a memory location or a immediate value or the register. So for addition, you are having two. One is and, the other is add with carry. And for subtract, SUBB, only one instruction we are having for subtract. For addition, we are having two instructions. So in your process, so if you look to add one immediate value, one small value you can add. You don't need to give the immediate value as hash one over there. Directly you can use it as increment A, increment register RN. So you can't add one RN. It is not possible. Only the possible case for addition of one value into the any register other than A is using increment. Increment term is that suppose if you have given R and INC RN, R will register bank register. Suppose if you have given an example is INC R0. So this R0 register is been added with one and the content of R0 is being incremented. Similarly, you are having decrement A, decrement R, and then where you are having obviously you can use for the data pointer registers also increment and decrement can be used for data pointer. Data pointer is for external memory if you want. And a very important two instructions are there near 8051. This is nothing but multiplication and division. Very interesting fact about that one. For both these instructions, you need to combine to A and B register. So when you multiply two numbers have to be fixed. One of the numbers should be stored in A, the other number should be stored in B. Then when you multiply this one, as already we have discussed, when you go for multiplication of two 8-bit numbers, the result may be 16-bit. So this 16-bit result is being stored such a way that lower 8 bits are stored in A, higher 8 bits are stored in B. So this is your resultant. Fine. And similarly, when you go for division, what division will do is that the numerator value has to be stored in A and the denominator value has to be stored in B. And when you go for division, the quotient is being stored in your A and the remainder is being stored in your B register. This is about the division. The decimal adjust accumulator not it does is that it will go for unpacked BCD to packed, packed BCD to unpacked BCD. Category is logical instructions. As we know that we are having a logical AND or XOR. Same thing here. The representation for AND is given as A N L and logical A and R. And here also the same thing. Destination should be an A only. You can perform AND operation for any number or memory location or immediate value, whatever it is there. But the resistance should be your A only. Similarly, we are having OR operation. In 8051, we are having AND or XOR. Okay? XOR L. XOR logical. AN L. XOR logical. These are the three things we are there. We are having first one is AND logical, ANL. Next one is OR logical, XOR logical. You know the table of all these things. Say three logic gates, whatever the operation. If both the inputs are one and it is equal to one, remaining all the cases it is zero. OR is zero for zero zero, remaining all cases it is one. XOR when both the inputs are same, output is zero. If complementary inputs are there, output is one. Similarly, you are having next one in this one like the previous instructions where here also we are having complement instruction CPL. CPL stands for complement, and here also same A register should be taken into consideration. CPL A what it does is that whatever the contents of A is there, it goes for the complementing the A contents and will be taken up A bar. Okay, this is A bar. So when you run a question as A, you will be getting when you go for CPL of A, you will be getting as complement. And if you want to clear up their A register contents, you can use CLRA because we are using for all the different processes we will be taking into consideration. One thing is that swap instruction is also being used. Swap what it is that the contents are lower 4 bits of A are being swapped to higher 4 bits of. So this is about one. And next one is R rotate left, rotate left to carry. These are all the instructions we have already discussed. Rotate left, one bit would be rotated to a left, and rotate left to carry would be rotated left on one bit. And the last bit would be coming in the first one, and it would be going to the right. So similarly, we can see the flow of this one. So a n plus 1 bit is being moved into the an, and like a0 bit is being moved to right till rotate right. It would move to the a7, and a7 bit would move a6, a6 to a5 like that where you can proceed, and a1 would be copied into what a0. This is the one rotation. So when you go for into consideration of carry flag, the A7 bit is been copied into the carry flag. From the carry flag, yeah, again it would be more rotated like that. So this is your here what happened? A0 bit will be copied into the carry flag, and from the carry flag it would move into A7. So A7 bit will be moved into A6 like that way it will proceed. So this is rotate right, rotate left. On this one, we already we have used the rotate instructions in your previous 8051 and 8085 and 8086. So now the on bits, it is like clearing the carry flag, clearing the one particular bit, like put bits of and setting the bits, complementing the bit, and logic with the bits or logic with the bit, moving an content to the bit. That is the all the instructions related to the bit. And last one is jump and call. Here you will be having different categories of call as well as jump. You'll be having absolute call. Call is nothing but calling a subroutine. You can call an absolute call. The address is being given directly in the program. A long call and return would be there. Okay. And here in categories of jump, we are having absolute jump, short jump, and long jump. Three categories of jump. Similarly, conditional jumps are there, like jump if carry, jump if no carry, jump if um, below, jump if below and carry. Sorry, jump if bit is set, and jump if bit is clear or it is not set. Like that way, short jump and long jump, jump if zero, jump simple, jump if not zero. Compare. This is one of the instructions which would be very used over here. Compare and jump if not equal. These instructions would be used. So, and compare if not zero.